all of those chapters that had all the algebra and the different functions kind of build up to a last section that's all about solving, right? So we know how to solve exponential and logarithmic equations. We know how to solve equations with roots and fraction exponents. We know how to solve polynomial equations. So we're kind of always building up to that. Well, we've been talking about rational functions, functions that look like fractions. They have polynomials in the numerator and the denominator. So we want to be able to solve those functions, okay, or solve those equations. Now, we've run into this issue before in some other chapters where we have what is called an extraneous solution. Remember, extraneous does not mean wrong. It means false. You did all the work right. The x is correct by algebra, but when you plug it back in, it doesn't work. In this chapter, that's because we have a fraction. If you plug it back into the fraction, it makes the denominator equal to 0. You have something undefined, and that's not an answer. So we say that would be extraneous, no solution. If there are other solutions that work, you could have those other solutions. But if your only answer doesn't work, then you have no solution. We've seen that with logarithms, right? We weren't able to take logs of 0 or negative numbers. So anytime our x made the thing behind the log a 0 or a negative, we would say extraneous. We saw it back with radical functions, like if you can't square root negatives, so that was an issue for us. So just kind of be aware that those things happen with different types of functions. Okay, we're going to talk about equations that are set up as fraction equals fraction. So that's my first example over here. Suppose you have 7 over x plus 3 equal to x over 4. Any ideas out there? How do you solve equations that look like a single fraction equals another fraction? Kenzie? Yes, cross multiply. I'll put this, cross multiply. You really learned how to do this. I know that you probably cross multiplied in algebra, and then you did it again in geometry when you're doing like similar figures and proportions and ratios, right? Anytime you have a ratio equal to another ratio, it's called a proportion, and you can solve it by cross multiplying. It doesn't matter if one of your numerator or denominator or both of them happen to be some like several term polynomial, you can still cross multiply. So let's cross multiply. Let's see, 7 times 4 is 28. And then remember, you're not creating another fraction, you're making an equation, so it's equal to x times x plus 3, so you got to distribute it, so it will be x squared plus 3x. Now, if you feel like you need to write that down, x times the quantity x plus 3, so you remember to distribute, you can. That's going to be kind of like an individual basis, what you need to write down and what you don't. How do you solve an equation like that, 28 equals x squared plus 3x? Make one side equal to 0, and then your choices would be factor or quadratic formula. So now we're using our knowledge from first semester, how to solve quadratic equations. Do you know factors of negative 28 that would add to make 3? 7 and negative 4. So we'll have x plus 7, x minus 4, which means our solutions are negative 7 and positive 4. Remember, you're dealing with an equation that looked like a fraction, and there is a limitation to all fractions. Fractions are not defined when the denominator equals 0. So if I take negative 7 and plug it back in, does it make either denominator equal 0? No. What about 4? Either denominator equal to 0? No. So neither one is extraneous, they're both good. So you could have both good, you could have one good, one bad, you could have both bad. If it's not quadratic, if it's only a linear equation, when you cross multiply, you'll only have one solution. Okay? And you should still check it for extraneous. Anybody got any questions on that first example? Okay, try one on your own. X over x squared minus 10 equals 3 over 2x plus 1. Since it's one fraction equal to another fraction, you should be able to cross multiply. Oh, this 2x can't be.
Yeah, I just put it in. I forgot that.
Okay.
Okay.
Those are not like terms. Okay, if I cross multiply, I get 2x squared plus x. And then that equals 3x squared minus 30. Of course, looking at my equation, I have x squareds and x's, so I'm going to think about factoring our quadratic formula at like one side equals 0. I always choose wisely. I always want my x squareds to be positive. So in this case, I would want to move everything on the left over to the right. So I like to factor with positive, so I'm going to subtract the 2x squared. That leaves me with 1x squared. I'll need to move the x over. Notice there is no x term on the other side, so subtract x and then minus 30. And now that equals 0. You got a trinomial. Do you have factors of negative 30 that would combine to make negative x? Negative 6, positive 5, so x minus 6, x plus 5 equal to 0. So my solutions are 6 and negative 5. Good? Bad? Extraneous? Good. Yeah. If you plug them back in, 6 squared is 36, so you subtract 10, no problem. Negative 5 squared, be careful what that one is. 25, not 10. So you can subtract 10, no problem. And then on the other side, it would be like positive 12 plus 1 or negative 10 plus 1. So no zeros in the denominator. You are good to go. All right, we'll do one more real quickly. We got 1 over 2x plus 5 equals x over 11x plus 8. If you cross multiply, you'll end up with an x squared and an x term, so you get them on the same side. I have 2x squared minus 6x minus 8. You can factor as is. Note that all three of those terms share a common factor of 2, so you can make your life a little bit easier. If you notice that, you can take out the common factor of 2, so that leaves me with x squared minus 3x minus 4. That doesn't always work that they share a common factor, but in the case that it does, you can take it out. And then do you have factors of -4 that combine to make -3? -4 and 1. So we'll have x minus 4, x plus 1 equals 0. Okay, that produces only two solutions, x equals 4 and -1. Some people will ask about, like, if they ever factor something out like that 2, they'll ask about the 2. Well, 2 doesn't have an x in it. So if you set 2 equal to 0, how do you feel about 2 equals 0? Not true, false, right? So there's no x to solve for. If you come up with something like that, 2 equals 0, it's not going to produce a solution. So you can kind of ignore any number terms that you factored out. Now, if you factored out an x, and you set x equal to 0, that would be an extra solution, right? But any extra numbers you can kind of ignore. Do both of those numbers work?
Yes.
Yeah, again, so we haven't run into any extraneous solutions, but you should always be checking for extraneous solutions. Plug it back in. Basically, you just need to plug it into the denominator and verify that the denominator is not equal to 0. Now, side note. If I wanted to actually check the accuracy of my answer, let's say you have extra time on your test and you want to make sure you did your solving problems right, you can plug x equals 4 into both sides and verify that they're the same, right? So, like, if x equals 4, this will be 1 over 8 plus 5, which is 13. And that should be equal to 4 over 44 plus 8, so 52. And sure enough, 1 over 13 is 4 out of 52 reduced. So then it works out. So if you ever do and check your answer, you can actually do an accuracy check by plugging it into both sides. Okay, last thing real quick is inverse function. Okay, tell me what you know about inverses.
You have to switch x and y.
Oh, that is beautiful. Thank you. You need to switch x and y. Your Algebra 3 and pre-calculus teachers are going to be so lucky to have you next year. You know that. Now, if it's a graph or a table of values, switch x, y, plot the new points, or list the new table, whatever that may be. If it's an equation, switch x and y, and then solve for y. Right. In an equation. So we do it a little bit more. It's really just a game of algebra when you're solving for y. So we've seen it in some different chapters, how we go about finding our inverses. F of x equals 7 over x plus 5. We'll do that one first. So we want to switch x and y. F of x is really y, so we're going to put x right there, equals 7 over y plus 5. How would you go about solving for y, Fish? Like you're multiplying both sides by y plus 5? Sure. So you might notice like your y is in a denominator, and we really don't have any kind of method for solving for things in denominators. We'd like to get them out of denominators. So you might think about that as like whatever's in the denominator, multiply it to both sides. That's the same thing you would get if you cross multiplied. X times y plus 5 equals 7 times 1. Okay. So you can also think about it like it's really just a cross multiplication as well. Okay, on this side, I'm going to go ahead and distribute my x here. I'll get xy plus 5x equals 7. Can you solve for y?
Can you do 7 divided by y? Like, can you move the y divided by y in half?
Well, you want to solve for y, you want to get y all by itself. So what are you going to move to the other side? You're going to move the other things. You're going to move this x eventually, so instead of dividing by y, you'll want to divide by x. What else do you need to move?
Subtract the 5x.
You gotta subtract the 5x, right? Anything that's being added or subtracted to that y needs to be put on the other side right away.
So you can't divide by y and then multiply by 7.
Then you'd get 49 over y. You know,
Yeah.
so it's not gonna help you. You got y up in the regular line of text when we multiplied by y plus 5. So we don't want to put y back in the denominator. We want to leave it up here. So yeah, I would subtract the 5x. xy equals 7 minus 5x. And now to get y all by itself, divide by x. Y equals 7 minus 5x. Notice your inverse to a rational function is another rational function. It looks like a fraction again, right? Has a numerator and a denominator. I'm going to take a little trip down memory lane here, back to the beginning part of our chapter 7.2. And ask you about my vertical and horizontal asymptote. So let's talk vertical asymptote. What's the vertical asymptote?
0.
X equals 0, because you set your denominator equal to 0. What about your horizontal asymptote? Y equals something, right?
Yeah. Would it be, is that considered an AX over BX?
It has an x in the numerator and an x in the denominator, so it's like our y equals ax plus b over cx plus d. Do you remember what the horizontal asymptote was?
It's
A over C.
A over c. Okay, so a and c, in my notes I said they're the LCs. What did I mean by LCs?
Leading coefficient.
Leading coefficients of your x terms.
So would it be
So it's 7
negative
over x.
5?
Whoa.
What's the leading coefficient to your x's?
So,
Negative 5. 7 doesn't have an x. Over 1.
Quinn, I'll be honest
So
with you,
ratio of
I
that
thought you
is
were really wrong when you said that. So
negative 5.
Thanks.
Okay, now, do we agree that's our vertical and horizontal asymptote for our inverse? Okay, let's go back up to the original function. What's your vertical asymptote?
0. Oh, not the original. I'm sorry. Negative 5.
X equals negative 5. What's your horizontal asymptote?
0.
Y equals 0 because there's no plus k. There's no x in the numerator, so this is a over x minus h plus k. Okay, what are you noticing?
They're flipped.
Inverse.
They're flipped because they're inverses. What did we just do? Switch to x and y. So now all the x's are the y's and all the y's are the
X.
x's. So it makes a lot of sense, doesn't it?
Can we do that?
What do you mean do that on this?
Just like.
Just to check,
Will
yeah.
they always be switched?
They'll always be switched because you switched x and y.
So can't you just know your answer without doing
Well, I might be asking you about the inverse, so I think you have to do the work for that. But if I asked you about domain and range or vertical and horizontal asymptotes, then you would, know your answer right away. Okay, we'll do one more. This one it works out a little bit differently. We got to be really thoughtful about algebra and how we're going to get y all by itself. So this one comes in the form ax plus b over cx plus d. Of course, to start the inverse, we would switch x and y. So I'll have x equals y minus 2 over y plus 1. What do you suppose you might do? It is being divided by y plus 1. So probably multiply by y plus 1. We can't solve for y if it's in the denominator of a fraction. You never solve an equation in the denominator of a fraction. You know how to cross multiply, right? So we probably want to move that up to the regular line of text, I say. So we're going to multiply by y plus 1, or you can consider that cross multiplying. It's the same thing. If I cross multiply x times y plus 1, then I'll just be left with y minus 2 times 1, which is what happens. Okay. So now I have y on the left and y on the right. So I'm going to go ahead and distribute here. So I call that xy plus x equals y minus 2. Okay. And what's our goal?
Isolate the y.
Isolate the y.
Try not to put it back in the denominator.
Don't put it back in the denominator. Leave it up where it is.
So, can you multiply by the other y and then square root?
I would not multiply by the other y because then you'll get like y squared.
You subtract
If you
that.
have y squared, can you-
Yeah, there's probably, so like just think about this. Do you see that you have y's on the left and y's on the right?
Yeah.
If you're trying to solve for y, where do you need all the y's to be?
On the
On the
left.
right.
On the
Together, that's-
same side. It doesn't matter if they're on the left or on the right, right?
So can't you put the other y back on the other side?
Okay, so how can we move y to the other side?
Divide. Subtract.
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 Sure.
Okay. So I'm going to have xy minus y equals, now my y's are on the same side. I really don't want this x over here because it doesn't have y.
Subtract it.
So it equals negative x minus 2 or negative 2 minus x. It's the same thing. Now, think about algebraically why you're doing that. You have multiple y's in your equation. In order for you to be able to solve for y, you need them to be together. Now they're together on one side. But xy minus y
It's not just y.
is not just y. So you have two things that are being subtracted. They both have y in them. So you can factor out a y from both terms. If xy minus y, if both of these terms have y, I could take y out. What's left over?
X minus y.
Another way where some people may see, how some people may see that is if you're doing xy minus y. Now that's like doing 3 y minus y. And don't you normally do like 3 minus 1 and you get 2y? So you would do x minus 1 y. It's the same thing. It's another way to see the same thing. I like to think about like factoring it out. That's how I see it. Factor out the y. And then can you get y all by itself?
Fine.
Good. Y equals negative x minus 2 over x minus 1. The answer to the inverse of a rational function looks like another rational function. Don't get cancel happy. Just leave it alone. You know, if you want to stop and check, does it make sense in terms of like switching x and y, vertical and horizontal asymptote? For your inverse, your vertical asymptote is x equals 1. Your horizontal asymptote is the ratio of the leading coefficients, y equals negative 1. Check up in your original, those things should be flip-flopped. Vertical asymptote is x equals negative 1. Horizontal asymptote is y equals 1. Yeah, we flipped them. Good stuff. All right, your homework assignment is another worksheet.